Okay, do you have any question? So let's look at section 8.4. So today we're going to look at section 8.4 and 8.5.
Did you post a quiz?
Yeah, I posted a quiz last night. So it's due on Wednesday.
Okay.
So most of the things in that quiz is what we're going to cover today. Okay, so section 8.4 is adding, add, subtract, and multiply radicals, radical expressions. Add, subtract, multiply radical expressions. So let's start from addition and subtraction. So addition and subtraction, you do it in a similar way. So addition and subtraction, you just do it in a similar way. So when it comes to addition and subtraction, it is what you call the like terms, or the like radicals in our case. So the like radicals. So when you're adding or subtracting, then you must have the same, you must add the same or subtract the same terms which are having the same radical or which are having the same exponential function. So in this case, let's say you're adding, let's say 3x plus maybe 2x. They are the same terms, right? These terms are the same. It's like 3x is they have the same x. So this is like what? 5x. So it is similar to, let's say you have 3 root of 2 plus 4 root of 2. These are having the like what? Like radicals. So you just add, or you just factor out. You can factor out the root of 2. And when you factor out the root of 2, then what remains inside is 3 plus what? 4. 4, which is equal to 7 the root of 2. So you add or subtract the radicals. So they should be of the same kind. If they are not of the same kind, so you try to simplify these radicals. So if you're adding, you try to simplify to get the same terms or the same radicals. For example, example number 1, simplify the 6th root of 6vu minus 4, the 6th root of 6uv. Yeah. So if you look at this, the radicals are what? They are like, right?
Mm-hmm.
So this one is similar to that. So then you can factor out. So when you factor out that radical, then the 6th root of what? 6uv, which is the same, which inside is what? 1 plus minus what? 1 minus 4, right?
Mm-hmm.
Which you get minus
3.
So minus 3, the 6th root of 6u. Okay, another example. 5, the cube root of 1250 plus 7, the cube root of 270. 5, the cube root of 1250, and 7, the cube root of 270. So first of all, looking at these radicals are not similar, but you can start by simplifying. So you can simplify. So you look for the factors of 1250 and 270. So like 1250 is similar to, so 1250 is similar to, so 5, the cube root of 125 by what? 10, right? And then plus 7, the cube root of, this one is 27 by what? 10, right? So this is 125 by 10, and then this is 27 by 10. Now, 125 is 5 raised to what? 3, right? Or 4? Is it 3 or 4?
Yeah,
Three.
3.
3. And then 27 is 3 raised to what?
3.
3 raised to 3. So therefore, it will now be 5, the cube root of 5 raised to 3 multiplied by 10 plus 7, the cube root of 3 raised to 3 multiplied by what? 10. Then finally, when you simplify the two of them, so it will be 5 factor out. So this cube root will divide that one. Then this is 5. The cube root of what? 10 plus 7. This will come out by 3. The cube root of 10. Then basically, this is 25, the cube root of 10, plus 21, the cube root of 10. So now, the radicals are what? They are like. So then it will now be what? You add. So it will be 46, the cube root of 10. 46, the cube root of 10. So you try to simplify, try to look for the like roots or the like radicals. So subtraction is similar to addition. So for example, if you're told to simplify the sixth root of 5x minus 3, the cube root of that. So looking at this, do we have a solution here?
No.
We don't have a solution, right? Because we don't have the like radicals here. So this is the sixth root, and then this one is the cube root. So they are not like. So you just leave it like that. So that is the solution. Okay, now when we come to multiplication of now the roots in the radicals, if you remember this, if we have if we have the nth root of A and the nth root and nth root of B, then the nth root of A multiplied by the nth root of B is similar to the nth root of A, B, right? We still remember that. So it is similar to that. And also, the nth root of A, B is similar to the nth root of A, the nth root of what? The nth root of B. So they are the same. Now, example. If we have told to simplify this, 5, the cube root of 3x cubed and 3, the cube root of 18x cubed. Again, when you're multiplying, the radicals should be what?
The same.
The same. Like this nth root, this is also nth root, so they're the same. So this radical should be the same. It should not be like if this one is cube and this one is square, it cannot multiply. If this one is cube and this one is square, you just leave it like that. So it will not multiply. So using the same method like what you've done up here, then this is the same as what? The 5, the cube root of what? And then there is 3 outside, right? Which is this and this. The cube root of 3x cubed multiplied by 18x cubed. So this is the same as 15, the cube root of what? 3x cubed multiplied by 18x cubed. Right? So again, this is the same as what?
3x.
15, and then how many 3's are there here? So we have 18, right? So we have 3, we have 6, right? Then 3, 2. So there are how many 3's?
2.
2, and this one, right? So there are 3. So the cube root of 3 raised to 3, and then x. How many x? X are what? 6. X are 6.
So could you not do like on the top of the last one, how you had, where was it? You had on the last problem, you had 5 raised to 3 times 10, and you had 3 raised to 3 times 10 on the previous problem. So, and the third power is canceled out.
Where did I put the previous one? Oh, this one?
Yes. No. It says right here. You had those big numbers. It was 5 to the third power to the 12, 15. So right here, you canceled them. You have 5 to the third and 3 to the third, and they canceled because
The power.
would that not be the same down here? Could they not cancel because you have 3x to the third and 18x to the third? Couldn't you just cancel those and have 3x and 18x?
Yeah, you can do that. But mostly we don't cancel. If you cancel, you might make a mistake.
Okay. I was just curious, because that's why you canceled them on the last problem, right? Because you had the
Yeah,
third power.
we basically we're not canceling. We are trying to multiply by 1/.
I see. Okay.
So you try to explain to someone that you're canceling. You'll
Okay.
be confusing that guy.
I see. Okay.
Yeah.
What happens to the 2? For the,
Oh, we have the 2. We have the 2 somewhere. We have not finished.
okay.
Yeah, we have not finished.
I got a question. Why can't you just take the 3 times the 18 and write x to the third, like, so it could be 54 x to the third?
Yeah, we are trying to simplify. Like, this is cube, right?
Yeah.
So we're trying to look for a way that this cube can simplify the whole equation. Instead of going a long way, like getting 54, and then now you come and still simplify. Yeah. So we start by looking for the factors of 18 there. So we have 3, 3, and then we have the 3 which was remaining here. Then we still have the 2 which is there. So therefore, this is like 3 raised to 3. We have this 3 here, and 3's which are here, which are 2. And then we still have 2 there, raised to 1. Okay? For the 18 here. Now, if we now simplify this, then multiplied by the power here, then it will be what? 15 multiplied by 3, right? 3 will come outside, right? And then x squared. And then the root of, the cube root of 2. So basically this is 45 x squared. The cube root of 2. That clear?
Wouldn't there be an x left in the cube, I mean, in the square root though, after you get it out?
When you say x raised to 6 multiplied by 1/3, it becomes what?
X squared.
X squared, right?
Yeah.
Which would come out. Yeah. So it will be now be 45 x squared. And then that. Now, if we have this other example, 2 the 4th root of 8y squared, and then minus 2 the 4th root of 12y cubed. Okay, so similar way with what we've done. So multiply first this and this. So you get what? Minus 4, right? So minus 4 here. And then, so this one and this one is minus 4. So I know most of you will confuse. There is a bracket here. So this is a bracket. It's not a minus, it's multiplication. Okay? So we are multiplying. So therefore, you multiply this and this, you get minus 4. Okay? And then now you operate on the radicals. So inside will now be the 4th root of what? 8y squared multiplied by 12y cubed. 12y cubed. Now, how many 2's are in 8?
3.
3. So 2 raised to 3. 12 is what? So 12 is 2 for 6, 2 for 3, right? So 2 raised to 2 by what? 3. So this is minus 4, the 4th root of. So how many 2's are there in total?
5.
So 5. So that means it will be 2 raised to 4 times what? Times 2, which is remaining, right? Times 3, which is there. And then y. Y are 5, right? So y 4, and then what? So finally, when you simplify, then it becomes minus 4 multiplied by 2 multiplied by y. Okay? And then the 4th root of is 2 multiplied by 3 multiplied by 4. So finally, you get minus 8y, the 4th root of 6 what? 6. 8y, 4th root of 6y. Simple, right? Very simple. If you follow the steps, then you'll be good. Okay. Now, if you're given, now like this, another example is, let's say you're given for the cube root of x plus 6, and then the cube root of x plus 1. Yeah. They're given something like this. So how will you simplify? So how will you simplify? Now, this is similar to what? Let's say a plus b, a plus what? B. You remember how we were solving this, right? So you can say a plus b, a plus what? B, right? So you do it just like this. So you can say the 4 root for the cube root of x multiplied by the cube root of x plus 1 plus 6. The cube root of x plus 1. Right? You can take it like that. You still remember when we were using we were expanding this. You remember how we were expanding? So these are, let's say these are the roots, okay? These are just the roots. Then when you want to expand this one, then you multiply this and this, multiply this and this, plus multiply this and this, multiply this and this. So it is similar to grouping them in this way. So you multiply this and this one, this and this one, okay? So when you open these brackets, then this is 4, the cube root of what? X, the cube root of x, right? So that is the first one. So this and this. Plus 4, the cube root of x. That is the second, this and this one. Plus, you come to the next 6, the cube root of x. And then the last one is plus what? Plus 6. So this is 4. The cube root of x, the cube root of x is what? So cube root of x, that is the cube root of x.
Cube root of x squared.
Yeah, so it's cube root of x squared,
Yeah.
which is what? Yeah, you can just say the cube root of x squared. Yeah, the cube root of x and then square. Okay, and then plus. Now, the next ones are the similar radicals, right? They have the same radicals. This and this. So it will be what?
10, 2,
10, the cube root of x. And then plus what? Plus 6. Plus 6. So you can just leave it like that. That is our answer. That is our answer. Okay. Again, you can be given simplify the cube root of 5 and then the cube root of 100 minus the cube root of 75. simplify that. So it's the same as distributing this, right? So you distribute the 5, the cube root of 5. So when you distribute the cube root of 5, then you get the cube root of 5, the cube root of 100 minus the cube root of 5, the cube root of 71, 75. Okay, so 100. How many 5s are in 100? So 100. 5 is what? 20. 5 is 4. Okay. So the cube root of 5, the cube root of 5 square, that is 4. Then minus the cube root of 5. How many 5s are in 75? So 5 or 4? 25, right?
No.
15. Right?
Yeah.
5 for 15, right?
Yeah.
75 times 5 is 15. So 5 for 3.
3.
Okay. So the cube root of 5 square. That's what? That's 3. Now, when you now combine, then it will be the cube root of 5. This and this are what? They multiply by 4 minus the cube root of 5. Raised to what? This and this are 3. Multiply by what? By 3. So finally, this one and this one. So it will be 5, the cube root of 4, minus 5, the cube root of 3. So from here, are you able to simplify further? No, right? Because this and this are not similar. But you can just factor out what? 5. But you cannot add this because they are not the same. Yeah, so you can just leave it like that. Just leave it like that. Any question up to there? Now, let's come to the next section, dividing radicals, which is section 8.5. Section 8.5. Divide radical expression. Divide radical expression. If, remember this, if nth root of A and nth root of B are real numbers, are real numbers. And there is an integer, which is, and this integer n is greater or equals to 2. This n here is greater or equals to 2. Then the nth root of A all over the nth root of B is equals to the nth root of A all over what? All over B. As long as B is not equals to 0. As long as B is not equals to 0. So in a similar way, the nth root of A all over B equals to the nth root of A all over the nth root of B. So that's similar. That's similar. As long as B is not equal to. If B is equals to 0, then it becomes undefined. It becomes undefined. Okay. Example number 1. The cube root of 243 u raised to 10 all over the cube root of 3u squared. The cube root of 243 u raised to 10 over the cube root of 3u squared. So using the same way up here, so it is similar to the cube root of what? 243 u raised to 10 all over what? 3u squared. 3u squared. Now, so when you simplify, when you cancel these 3 and the other one, what do you get? 81. 81, right? So you get 81. So this is equals to the cube root of 81. And then u and u there. So u raised to what? 8, right? U raised to 8 because this is 10 minus what? Minus 2. So u raised to 8. Now, factoring this 81, that 81 is 3 raised to what?
3 raised to 4.
So 3 raised to 4. So which can be written as the cube root of 3 raised to 3 minus 3, and then times what? U raised to what? U raised to what? So that is actually what? 6. And then U. And then finally, this is equals to 3 u raised to 2. And then the cube root of 3 u raised to 2. So you can do the others just like this. Now, let's come to the next section, which is rationalizing. How we rationalize, I don't know where my notes went. Now, rationalizing. Now, if you are given as to rationalize, if we have one denominator, so if you have one denominator. So, for example, if you have 1 all over the root of a, 1 all over the root of a. So, how should we simplify this? So how should we simplify? So here, we can simplify this by multiplying by rationalizing this. So we multiply by the root of a over the root of what? A, right? So the root of a all over the root of a is similar to 1 because this and this can be 1. So basically this is the same as the root of a all over the root of a. The root of a is what? Is a, right? Because the root of a squared,
Right.
right? And this one is the root. So then it becomes what? It cancels. So you only get a. So this is equals to the root of a all over a. Because the root of a is similar to the root of a squared is equals to a. Right? Because the root of a, when you use a product, when you multiply this, then this and this is a squared. The root is 1 over 2. So it becomes a. So this is how to simplify. How to simplify. Now, we have this example. 5 all over the cube root of 169 W. Simplify. Now, how should we simplify this? How should we simplify? What can we do to remove this radical here?
Multiply it by cube root of 169W.
So if we multiply, then we only get square. The square of that. So what we do here is we multiply by the square of all of this. So if we multiply by the square of this, then it will be 1 over 3, and the other one will be 2 over what? 3. So 1 over 3 plus 2 over 3 is what? Is it not 1?
Yeah.
Yeah, it is 1. So what you do here is you multiply by the cube root of 169W squared all over the cube root of 169 squared. Because this is 1 all over 3, and this one will be 2 all over 3. So when you simplify this, you get what? 1. So therefore, this is equals to the 5, the cube root of 169 W, and then this is square. All over 1. Because this is 1, then it will be 169. 169. So you look for a way of removing this radical down here by rationalizing. You rationalize that radical. Another example. Simplify the square root of mn all over the square root of 252 mn cubed. So this is equals to the square root of 63 mn all over 252 mn 252 mn cubed. So is 63 dividing 252?
Yeah.
4, right? So what do you get? The cube root of, the square root of mn all over 4 mn cubed. So this m and that one will cancel, this n and this will be what? Square, right? So therefore, this is
Can you push the paper?
so this is the square root of 1 over 4n squared, right? 4n squared. So the square root of this one is equals to what? So it is equals to what? So this is similar to 1 all over the square root of 4n squared, right? Right? Because the square root of 1 is 1, which now be equals to 1 all over 2, the absolute value of 1. 1 all over 2, the absolute value of n. Okay. Now, let's do the last one before we break. The root of 7 all over the root of q plus the root of 13. Simplify that. Simplify that. So what do you do here? You multiply by the what? Conjugate, right?
Mhm.
And the conjugate of this is minus here. So it will be similar to multiply by the minus the root of 13 all over minus the root of 13.
So you basically just do the opposite.
Yeah, you multiply by the conjugate. The conjugate. So this is the conjugate. Now, the below one is a difference of 2 squares, right? So the denominator is a difference of 2 squares. So the numerator will be the root of 7 multiplied by the root of 13 all over. This is a difference of 2 squares. So that means you square this minus the square of 13. So it will be q minus what? Minus 13. Q minus 13. So the last one, we have 5 more minutes. So if we have 9 plus the root of 17 all over 9 minus the root of 17. So again, simplify that. You do what? Multiply by the conjugate, right?
Mhm.
So the conjugate of the denominator is 9 plus the root of 17 all over 9 plus the root of 17. Which will now be, so these and these are similar, right? So it is 9 plus the root of 17 squared. All over what? The below one is a difference of 2 squares. So it will be 9 squared minus what? 17. 9 squared minus 17. Because when you square 17, root of 17 will become what? So it becomes 17. So finally, this is equals to 9 plus what? The root of 17 squared divided by 81 minus 17 is what? Is it 64? Yes.
Why isn't that just like 1?
Which one is one?
Because it's the same, basically the same thing, right? 9 plus the root of 17 and 9 minus the root of 17. Like if you were to have like 3 over negative 3, it would just be like negative 1, right?
Which one? This one?
Yeah, I'm just
becomes 1?
Yeah,
No,
why
no,
not
no.
just like one?
No, it cannot be 1. It cannot be 1. This is a difference of, this is the product of this. It's not a subtraction.
Yeah, but it's a fraction, right?
Yeah, but this and these are product. Oh, you mean this one cancel with that?
Yeah, what I'm saying.
No,
is-
we are
what I'm
trying to-
saying is like, you have like 3 over -3, just being like simple, it equals what, -1, right? So that one's 9 plus the root of 17 over 9 minus the root of 17. How come that can't simplify into like 1?
No. It cannot. This is a plus and this one is a minus.
Yeah.
So it is similar to A plus B all over A minus B. Is it 1?
helps you to do a really complicated form of 1.
So when you
Basically
say-
what I get out of it.
Let's say you say A plus B all over A minus B. Is this one equals to 1?
No.
It's so it's the same. Yeah. So you need to rationalize the denominator. So when you rationalize this one, now you can simplify. So this and this is a difference of 2 squares. This one and this is similar. So you now square. So you only square. So any question after that? So I think some of the questions in your quiz are from this section. This section. So let's do one and B. So it's only 4 or 5 questions. I think there are 4 questions. So if you don't have any questions, then we can meet on Wednesday. The semester is almost coming to an end, right?
Mm,
And we only have 3 weeks of teaching.
Do we? Alright, I know that.
And then you go for, you do an exam and then you go for the spring break. Yeah, so there are 4 questions in the
So we have 2 weeks of spring break, right?
It's only 1 week, the last week.
Oh, it is only a week.
Yeah.
Because only like, we don't come back after spring break.
Yeah.
Yeah, you want
3
to-
more weeks in the semester?
But the last week is a review,
It's just, yeah,
so you don't be coming to class and review what you know.
And then you're gonna drop the final exam for us, right?
There is no dropping of the final.
you say you're dropping a quiz or 2, right?
So the only thing I will drop is the quizzes. So make sure you do your homework. I saw some of you have not done.
I don't think you should drop any quizzes, that's just like keeping my grade.
Yeah, if you don't do your homework, you know you get a penalty.
Right.
Yeah.
So
So
you
try-
say you'll back them out for us?
Huh?
You say you'll back them out for the homework? You'll like extend it? The deadline?
No one is telling me to extend, so.
You extend mine? I have like, last week was hell for me, so I have 3 or 4 that I need
Okay,
extended.
I will extend the last 1 week.
Okay,
1 week, right?
I think so.
So,
It was a 7 point whatever.
okay, I will extend the one for 7 point.
Okay.
So make sure you.
Yes. I started getting caught up.
Okay, so make sure, I will extend the last 2 weeks.
Perfect.
Thank you.
So you make sure you finish that by, when is the deadline? When can I give you the deadline? Friday.
Friday would be wonderful. Yeah, that's what mine is 7.1 and 4 are the ones that I have, that I didn't.
Okay, I will extend the last 2 weeks.
Thank you.
Thank you.